Our group project is called MRA, which is short for Mobile Robotic Arm. Our group members are Jose de Jesus, Gustavo Raya, Johnny Balderas, and Omar Gutierrez. So, why did our team choose this project and what problems were we trying to solve? Our team chose this project because we wanted to create a mobile robot that could move autonomously and perform tasks such as picking up objects. There are many projects out there that have similar ideas already, such as a robotic arm that is controlled via a controller or a mobile robot that can pick up items with a platform attached on top of it, as you can see in the pictures above. Um, we wanted to go a step further and implement the best of both worlds, so we created a mobile robot that can pick up uh, items using object detection software and place them where they need to be placed, all while being autonomous. We've seen systems that have autonomous mobile robots like the Gray Orange Butler system, but they don't exactly have a robotic arm or are able to detect objects. And the problem we are trying to solve is we want to have a more autonomous robotic arm in order to reduce human errors as well as improve efficiency in places like storage areas. Our targeted audience are warehouses, sorting facilities, and possibly small shipping docks. Our project's main features are the line sensor, the object detection camera, and the robotic arm to pick up objects. Um, the objective with this robot is that we wanted to start at a certain position, then have the robot follow a line, and once the camera on the robot detects an object, depending on the color of the block, the robotic arm would grab the block and carry this block until it reaches the block's destination point, where the robotic arm would then proceed to place this block, and this process would continue until all the blocks we had placed down initially are moved to their destination point. Uh, for the base of the robot, Gustavo had 3D printed a frame that would carry all of our components, such as the two DC motors, the L298 motor controller, the Arduino Mega 2560, the power supply, the Pixie 2 camera, the line sensors, and the robotic arm. We use many external resources, but the three main resources that we use are displayed up above. So this timeline uh, was our initial implementation of the project, and it includes the project management style, which we followed a bi-weekly agenda. Um, for the most part, we tried to space out the project implementation the best we could, and we stuck to the project's timeline well enough, and we were on track to complete most of the project. Um, Again, our project management style was that each individual team member had been given a task to complete in order to finish the project faster. For example, Gustavo and Johnny were responsible for implementing the base and robotic arm. Jose was responsible for the object detection, and Omar was responsible for helping in research and obtaining equipment. And this is our updated timeline. Here you can see how our timeline changed throughout the project due to constraints and changes in designs. For example, we realized that our servo motors were not working properly, so we had to swap them out with ones that we knew would work and were authentic servo motors. We decided it would be best to go with the Pixie 2 camera in order to do the object detection we needed. We also had to redesign our base from the inside so it wouldn't be cluttered and hard to work with. Jose?
So our initial, like Johnny mentioned before, our initial design was supposed to incorporate the Raspberry Pi camera as a object detection. Um, there were some challenges challenges using it because I had trouble downloading the necessary software to officially implement it with our project. But we got it to detect certain objects, but not the objects we wanted it to. So we decided with the new. Can you go next slide?
Mm-hmm.
So we decided to go with the Pixie 2 since it was a bit easier, user friendly to use, and this was implemented by Johnny and Gustavo. Some of the challenges they were having was training the Pixie 2 since the area had to be well lit so it could detect the object. And once you trained it in that situation, you had to have it in a similar situation. So if the lighting was a bit off, the Pixie 2 camera would have a bit trouble actually detecting the object. The second one was getting the values for the X, Y, the width, and the height of the block on the using the serial port monitor, so we could so the robot could know where the object is, the coordinates, and from there it could basically use the robotic arm to actually pick up the object from that coordinate. Mm, next slide,
Okay, so
Gustavo.
Johnny and I were responsible for implementing the robotic base, which consisted of components such as a DC motor, power supply, the H bridge for the DC motors, the Arduino Mega, um, installing and implementing 5 volts to a breadboard and an 8-volt port for the DC motors. Another component was the IR sensors to um, have the robot track aligned to get it to specific locations that we wanted it to. Some challenges that we faced at first was a power supply not providing uh, power to the Arduino like we wanted it to. So we fixed that by checking uh, all the wires, making sure they were making connections. The line sensors were actually not functioning correctly the way we wanted it to. So the way we fixed that again was adjusting the line sensors and making sure we had the proper distance to detect the line. The DC motors weren't reacting how we wanted them to with the IR sensors, so we had to fix that in our code, which is a bug, which wasn't too hard. Um, we also found that we had a two voltage drop um, with the H bridge, so we had to compensate with that, compensate with that, and that was basically it for the robotic base. Next slide. Again, Johnny. Well, this time Johnny and I and Jose were responsible with implementing the robotic arm. We did have it sent out to get 3D printed, which came out perfect. Um, we installed servo motors and mini servo motors to specific joints of the robotic arm to function as we wanted it to. Some challenges that we faced here again were one servo motor was dead on arrival. Um, Servo motors weren't working correctly as we wanted it to. They would continuously churn when we had programmed it to stop. So that was another issue we ran into. Um, the gripper would want to open and close, which we corrected in our code, but we're still having problems with the servo motors that we were using due to um, authenticity. Um, and that's it for this slide. If you can go to the next slide. So this is an old demo. So this was our first demo. We used um, ultrasonic sensors for testing purposes. As you can see, it was a rough demo, but we later improved. And next, we will show you a demo using the Pixie 2 camera that we installed. So this is the complete model of our robot, and here is the demo.
What we learned from this project, we learned that time management is key to finishing any project. We learned having a good objective initially is good because it would have cleared a lot of doubts we had and would have made the path that we wanted to take with this robot a lot clearer. We learned that understanding code really helps because we may have had the hardware part down, but with the software part, we wouldn't be able to use the hardware properly. Splitting up the workload can help a group finish faster, which is what we figured out doing. We figured out doing this in our project. Good communication also really helped to piece ideas together and allows our group to finish faster. Much like understanding code, knowing how to use software tools such as Autodesk can really help as well to bring ideas to life. Finally, knowing what components to use beforehand really helped in order to avoid spending on unnecessary items. Our plans for our project in the future, well, we would like to implement this project inside of a warehouse or storage area facility in order to store items. We would like to further develop this project to make it more efficient, such as adding a better managing system, a rechargeable station, a bug boost converter. We would like to receive funding to build a better prototype of our project for a company that may see this project as useful in terms of productivity and efficiency. We would also like to further develop the code in order to make it look a lot cleaner and more readable to anyone that intends to use it in the future. The cost for a project, this is our outline with most of our expenses. As you can see, there are the main components that we had to purchase in order to build our project. Of course, there are other minor costs such as screws, bolts, nuts, and possibly purchasing tools such as drills and angle grinders, but these were our main expenses. Thank you for your time.